This is the aluminum version of my AR2 6-axis robot. This robot's completely open source. It's pretty easy to make yourself. It can be made out of aluminum, or as you can see here on the left, you can see it can be made out of ABS on a 3D printer. If you've seen my other video, you've seen this robot in action. After the demo here, I'll go over some of the details, some of the updates, and go over how you can make this robot yourself. So as you can see there, the robot can lift a capacity of 3 pounds. It could actually lift a little bit more, a little closer to 4 pounds, but I didn't have a 4-pound weight. And then also the repeatability, as you saw there, it's close to 30 thousandths repeatability, which I think is fairly decent considering the cost of this robot. This robot to build out of plastic would run you around $1,100 to make it out of plastic. And if you wanted to make that out of aluminum, it would be a little closer to possibly $1,800, depending on how much interest there is in it. After the last video, I had a lot of people ask me, what would you use a robot like this for other than a demo like this? So here's a couple ideas. The robot can be hugely helpful in the kitchen. The AR2 robot can chop onions. The robot can open your beers for you. You can program the robot to slice tomatoes. The robot is great for pouring drinks at parties. I'm just kidding. You'd have to be a real jackass with way too much time on your hands to program a robot to do any of those things. But we do plan on putting this robot to work in a machine shop, loading and unloading lathes and mills and a few other tasks. So I'll have videos of those operations coming in the future. A couple upgrades on this robot. I've upgraded the motors on axis 1, 2, and 3 to be the new Stepper Online Precision Series motors. That's this motor, that one, and the one down there. These are a much tougher, much more precise stepper motor. They don't cost a whole lot more. They're still really inexpensive. All the gear drive stepper motors and drivers, power supplies from Stepper Online has been the best place I've found to get any of this stuff. There's a link for that down in the description. All the other components in the robot itself are all off-the-shelf components I got from Amazon, McMaster, eBay. So most of the belts are LX series belts. All the bearings are off-the-shelf bearings that I got from Amazon for, you know, between $8 to $10 each for the bearings. Standard hardware from the hardware store. I did develop a wiring harness, so I'll show you in a minute here on the project page, where you can get all the instructions on building the robot, step-by-step instructions to build it, full instructions on how to build the wiring harness, and then also how to build this electrical enclosure over here. This electrical enclosure I upgraded to use DM542T digital stepper drivers. You can tell in this video they're much quieter, they have a lot more torque, and a lot smoother. It uses an Arduino Mega, and it uses an 8-channel relay output board. I use the 8-channel relay output to control solenoids, for example, for the gripper, or anything else that you would need. The enclosure design is designed with an e-stop circuit and a fence circuit, so you could tie it into anything you needed. The power supplies in there also available from Stepper Online. This particular one is a 35 volt power supply. I may bump that down to a 24 volt power supply, I'm not sure. The cables that you connect the robot to the controller, the signals from each of the limit switches goes over Ethernet, and then the rest of the motor connections just go over a standard ATX 24 pin extension cable that you can get on Amazon for a few bucks. A couple other things about this robot. To calibrate the robot, it has very inexpensive limit switches on each axis, so you can run a calibration routine. I'll do that now. So if I hit auto calibrate, the robot is going to go to its full limit in each direction until each individual switch is made. And then once each switch is made, it sends a signal back to the software to zero the robot out in the position it's in. So you can recalibrate this robot at any time, but it holds calibration really well. So if give it a second here, it's gonna so now I can see in the software it tells me that the robot is fully calibrated, and then I can run it back home. So you can recalibrate the robot at any time. I also set up a procedure for fine calibration where you can set a reference position. I'll cover that in another video in calibration, but you can do a fine calibration, so if you're off by just a couple of steps, you can fix that as well. So it stays really accurate. It's really been a pretty great robot. So if you come here to the project page at GitHub and go to my page, chrisannan/AR2, you'll find the home page for this robot project. If you scroll up here a little bit, here's all the downloads for all the files you would need. The first one, we have electrical schematic. That's just the schematic in a PDF you can look at. I also have the kinematic model for all the mathematics and how I did the mathematics. I laid them all out in a spreadsheet, and then I made a series of 8 videos that go through the math. So if you're interested in knowing how the robot kinematics work, I laid all that out. Right here we have the print files. You can download this if you want all the STL files to print all the components for this robot on your 3D printer. Right here we have the software executable files, so if you don't want to install Python and you just want a simple exe that runs, you download this and you can run the program. If you want to play with a source file or modify it, that's here too. You can download the source file. Here's the step files if you want to try and make the parts out of aluminum. And then we have the manuals here. I have the manual for building the electrical enclosure, the manual for the arm assembly, building the arm out of ABS, and I will be putting together another manual showing the aluminum robot going together. And then this manual I just put together, the wiring harness manual. Then we have a bill of materials. The README file is just this down here, the cover page. And then here we have the sketch. This is the program that gets loaded on the Arduino to run the steps, and it keeps all the motors working together at the same time, and controls the drivers. So you can click on here just to see the code, or you can just download it in a zip file if you want the whole folder. As far as the manuals, this is the manual for the wiring harness, so it's a pretty comprehensive manual. I'm just going to scroll through it really quick. So on this manual I put in all of the the bill of materials, everything that you need to build this manual, and then I go through every detail of crimping the wires, connecting all of the connectors, how long to cut all the wires for the limit switches, the motor pigtails, and then I go through the lengths of all the wires, putting them all together, testing them, color coding them, and then the final assembly. I'm going through this very quickly, but there's a completed wiring harness there, and then it goes through and shows you how to install the wiring harness on the robot. And I also have the manual on the assembly for the plastic version, so if we scroll through that real quick, you can see it goes through the complete assembly, every step of assembling the robot, how to install every bearing, every component. This manual goes through wiring it up if you don't want to use a wiring harness, but I would suggest following the wiring harness manual. So at the end of this manual you can see a completed built robot. And then I also have a manual on the electrical enclosure. Again, bill of materials, everything you need to build the electrical enclosure, complete layout, how to put it all together, how to wire it up. Goes through pretty much everything, including all the dip switch settings on the drivers. It also includes the schematic in here, and then startup procedure. Now, if you have the source code file and you've downloaded the source code file, you can just open that up, and in here you've got AR2.py. This is a Python file. You can just open this up and open up the software, but you need to have Python installed and the PySerial module installed. You don't want to do that, you just want it simple. You can run the exe file, you can download the exe file, and right here, this AR2.exe, you would double click that and it would open up the program. So we'll do that now. Open up the source file. So this is the program you use to program the robot. Over here we have a window where we can build a program and we can program positions. You can set the COM port you're on, you can load a program, you can play the program, step forward and reverse and stop. You can jog in joint, or you can jog in XYZ, yaw, pitch, and roll. You've got all of your buttons here to add items to the program. You can teach new positions, modify, delete, call programs, return from a program, wait for a period of time, wait for inputs and outputs to come on and off, set outputs on and off. You can, there's navigation. I have these tabs in here so you can jump around based on conditions, so you can jump if you need to. You could just, statically jump to a tab, or you could jump to a tab if an input's on or off, or if a register, you've got these registers that you can use as counters and incrementers, and you can jump to different parts of the program based on those. You can also control servos. If you have servos attached to your robot or some other item in your project, you have that ability there too. Down here it shows, I put a little some text here that tells you the Arduino which inputs, outputs, and which pins are set up already for the servos. When you run the program, you can just teach new positions. So for example, if I wanted to jog the robot forward here, I can jog the robot forward 100 millimeters and then teach a new position. And then when I start executing the program, you can see it turns blue and follows through the program. So it's pretty intuitive, being able to create a program. It'll show you what row you're on. A couple other things. We have a tab for calibration. This screen, this is where you would auto-calibrate. If I hit that button, the robot, which I showed earlier, will go to its full limits in each direction. Also, we have some buttons here for doing a fine calibration and setting a reference position. And if you're setting the robot up and you're not ready to calibrate yet, but you're stuck at an axis limit, I put in this button for force calibration in mid-range so you don't get stuck on axis limits, but that's just for messing around in startup. The software can also be used for your own robot. If you don't want to build this robot and you've got your own robot that you want to build, in here's all of the calibration values, and I'll make a separate video on how to calibrate the robot. But basically, you put in the negative and positive limit of the axis and how many steps it takes to move that direction. So those are all of your axis limits and numbers of steps taken. And then over on this side, you've got all your Denevit-Hartenberg parameters. So the series of videos that I put out on robot kinematics explains this pretty well. So if you built your own robot, you could follow that set of videos and then change these parameters. These are basically just the angles and link lengths for the wireframe model for whatever robot you built. So this software can be used for your own robot, custom robot, pretty much any, whatever you want. And then I've got a tab for inputs and outputs and servos. So all these servos here, you could put in a value, 180 degrees or whatever you want to drive it to, and then you hit the button and it will drive that servo, so you don't have to do it from the command line in the program. Also digital outputs on and off. My grippers are tied to output 45, so if I can just use those to toggle my gripper open and close. So that pretty much sums up the software. Let me know if you have any questions. on the project page here. You can find my email address right here, so if you have any questions, shoot me an email. I'll be looking at possibly offering an aluminum parts kit, so please let me know if that's something of interest to you. It'll completely depend on how much interest there is out there, and quite a bit's gone into this project, so if you want to donate, I'd certainly appreciate it. Alright, thank you for watching.